This is the monthly review for Semester 1. This is for Chemistry Grade 9, and my name is Miss Rayan. So we've got an atom. This contains a nucleus and an electron cloud. In the nucleus, there's nucleons, which consist of protons and neutrons. And in the electron cloud, there's electrons. Some atoms are big and some atoms are small, and this depends on how many protons, electrons, and neutrons they have. The subatomic particles are the protons, neutrons, and electrons, and these are not evenly distributed in an atom. The protons and neutrons are in the nucleus, and the electrons, they orbit the nucleus in layers called shells. So this is the characteristics of subatomic particles. Firstly, we've got a proton. This has a +1 charge and a mass of 1 AMU, and it's found inside the nucleus. Then we have a neutron, which has a 0 charge, and it has a mass of 1 AMU, and that's also found inside the nucleus. And then we have an electron, which has a charge of -1, which is opposite to a charge of a proton. They're opposite charges, and a mass of, it's negligible compared to proton or neutron, so we say it's 0, and it's found outside the nucleus. Now we'll talk about the atomic number. An element always contains the same number of protons, so hydrogen atom will always contain 1 proton, a carbon atom will always contain 6 protons. It is known as the atomic number, and it's found here. It's the smaller of 2 numbers shown in most periodic tables. Mass number is the amount of protons and neutrons in an element, and it's shown in the number of the top in the periodic table, so this number here. The mass number does not take into consideration the amount of electrons in an atom, because electrons have a mass of almost 0. So do you remember that we said in the periodic table an element looks like this? We'll have the element symbol here. Let's say it's called X. We have the mass number here, and we have the atomic number here. We said the atomic number is the number of protons. However, also in a neutral atom, the number of protons equals the number of electrons. The number of electrons changes depending if it has lost electrons or gained electrons. If an atom loses electrons, it becomes a positive ion. Take sodium for example. The 11 here shows us that it has 11 protons, and if it is a neutral atom, it will also have 11 electrons. However, the plus here shows us that it has a lost 1 electron, and therefore it has become a positive ion. So now it will have 11 protons but 10 electrons. If an atom gains an electron, it becomes a negative ion. For example, chlorine 17 here shows us that it has 17 protons. In a neutral atom, it will also have 17 electrons. However, this minus here shows it has gained an electron, so now it has 17 protons but 18 electrons. So to find out the number of neutrons, we said that in the periodic table, for example, we've got an element. In the element, we've got, for example, element X. We've got here the mass number. Here we've got the atomic number. And we said the mass number is the number of protons and the number of neutrons. And we said here the atomic number is the number of protons. To find the number of neutrons, we have to minus the mass number from the atomic number. So we have to minus this number found here from this number found here. So to find the number of protons, electrons, and mass number, we use these equations, okay? So A is the mass number, Z is the atomic number, and N is the number of neutrons. To find out the mass number, we do the atomic number plus the number of neutrons. To find out the atomic number, which is Z, we have to have the mass number minus the neutrons. And to find the neutrons, we have to take away the mass number from the atomic number. So the charge of the nucleus. Remember we said that the nucleus contains protons and neutrons. So the charge of the nucleus, charge is Q, is the number of protons times charge of one proton, and number of neutrons times charge of one neutron. But we said that neutrons don't have charge, so we're going to cross this out and write 0 next to it to show that the neutrons don't have charge. So effectively, the Q nucleus, the charge of the nucleus, is the number of protons times the charge of one proton. To find the charge of the cloud or the electrons, we have the number of electrons times the charge of one electron. Remember, in a neutral atom, the number of protons equals the number of electrons. So if we're going to take aluminium, for example, Al, this is the number of protons, and therefore in a neutral atom, this is also the number of electrons. So to figure out the charge of the cloud, we times it with the charge of one electron, which is -1. So we do 13 times -1, which equals -13. Please remember to not forget the minus sign before writing your answer. So the charge of the atom. This is the charge of the nucleus plus the charge of the cloud. We said the nucleus contains protons and neutrons, so the charge of the nucleus is the charge of protons plus the charge of neutrons, and we said that the charge of neutrons is 0, and the charge of the cloud is the charge of an electron. So effectively, the charge of the atom is the charge of protons plus charge of electrons. If we have Al, for example, and we said that the atomic number for Al is 13, and we figured out the charge of protons is +13, and the charge of the electron is -13. In a neutral atom, the charge of the atom will be 0. So the atomic mass is the mass of protons, mass of neutrons, and mass of electrons. However, we said the mass of electrons is effectively 0. So it's the mass of protons plus the mass of neutrons, and this is represented as AMU. So the mass number in AMU. So isotopes are atoms of the same element that have the same number of protons but different number of neutrons. Let's take Cl, for example. This can either exist as Cl17, its atomic number, and the mass number is 35, but it also can exist as Cl17. You see the number of protons did not change, but its mass number is 36. So this will have, remember, to find out the number of neutrons, we'll do the mass number, so 35, minus the atomic number, which is 17. So this will have 18 neutrons, and this one will have n equals, remember, the mass number, so 36, minus the atomic number, which is 17. This will have 19 neutrons. So isotopes have the same number of protons, but different number of neutrons, or different mass number. Electron arrangement. Electrons are arranged in different energy levels shells around the nucleus. The first level has the symbol K and it has 2 electrons. The second level has the symbol L and it can fit 8 electrons. The third level has the symbol M and that can also fit 8 electrons. The fourth level has the symbol N and that can fit 2 electrons. The group has the same number of electrons in the outer shell, so the group tells us how many electrons in its outer shell, and the row has the same number of energy shells. Let's take group 1 for example. We have lithium, and that has 3 number of protons. In a neutral atom, number of protons equals the number of electrons, and its electronic configuration is K2L1. We take the element directly below it, so in the same row, for example 11 Na, this is K2 L8 M1, and you can see that these have the same number of electrons on the outer shell because they belong in the same group. We said in the row we have the same number of energy levels. Beryllium is in the same row of lithium. This has 4 protons, which means it has, in a neutral atom, it means it has 4 electrons, so the electronic configuration is K2L2. And as you can see, that this has the same energy level, so here it ends with L, and here it ends with L. If we take magnesium, for example, which is in the same row as sodium, 11Na, magnesium has an atomic number of 12. So this is the number of protons. In a neutral atom, the number of protons equals the same number of electrons. Its electronic configuration is K2, L8, M2. You can see here that these have the same number of energy shells. So this one has K11A has KLM. Magnesium also has KLM. Chemical bonding. We have 2 types of chemical bonding, covalent bonding and ionic bonding, but today we're going to focus on covalent bonding. So there are 3 types of covalent bonding: single, double, triple. Single is represented by 1 line, double is represented by 2 lines, and triple is represented by 3 lines. So these are examples of covalent bonds. We have, as we said, single, double, and triple covalent bond, but let's focus firstly on single covalent bond. This is when 2 atoms can share a pair of electrons. For example, if we take hydrogen, this has 1 valence electron, and this bonds with another hydrogen, which also has 1 valence electron. You need to remember that hydrogen obeys the duet rule. So these will share a pair of electrons to become like this. And this is a single covalent bond. Double covalent bond is when 2 atoms share a pair of electrons. For example, oxygen has 6 valence electrons. So let's draw oxygen. 1, 2, 3, 4, 5, 6. And we said when 2 electrons are next to each other, we can write it like that. Another oxygen is the same. These are next to each other, so we can write them as lines, and they share electrons. So this electron shares this electron, and this electron shares this electron. So we effectively can write it like this. And this is a double covalent bond. Nitrogen has 5 valence electrons, so 1, 2, 3, 4, 5. Another nitrogen has 5, 1, 2, 3, 4, 5. This can be drawn as a line. This will share this, this will share this. Effectively, this will share this. So we can draw nitrogen like this. And this is called triple covalent bond. Now we'll do the questions on the review sheet I have given you. So the first question says, determine the atomic number of the element that occupies the third group and the second period of or row. Remember, this is the row. These are rows. This is the group. So when it says the third group and the second period of row, so we're talking about the second row, so it's this row here, and the third group. So we're talking this is the first group, this is the second group, and this is the third group. So we're effectively talking about boron. So this is the answer, third group. This means it has 3 electrons in its outer shell. Remember that the group number tells us the number of electrons in its outer shell. The second row, this means it has 2 energy shells. So remember, K is the first energy shell and L is the second energy shell. Therefore, the electronic configuration of this element is K2L3 because it has 3 electrons in its outer shell. This shows us the number of electrons. So number of electrons will be 3 plus 2, which equals 5. Now remember, in a neutral atom, number of electrons equals the number of protons. So this will also equal 5. So the answer is Z equals number of protons, which equals 5. Part 2 says, what's the electronic configuration of the first noble gas? The noble gases are located in the last column, so group 8 or group 0. It says the first noble gas therefore will be helium. So the answer is Z equals the number of protons in a neutral atom. Number of protons equals number of electrons. Helium has 2 electrons, so the electronic configuration is K2. So we have to give the family's name where magnesium and beryllium belongs. This is beryllium here, and this is magnesium here. So the answer is alkaline earth metal. Group 2 is called alkaline earth metal. So question 1, part 4, 4.1. Atom X belongs to row 3 and has 7 electrons in its outer energy shell. Identify the number of protons in atom X. Now it says 7 electrons in its outer energy shell. This automatically makes me think that it's in group 7. So this is group 1, this is group 2, this is group 3, this is group 4, group 5, group 6, and group 7. And it says it's in row 3. So this is row 1, this is row 2, row 3. So we are looking at chlorine that's here. Now we have to identify the number of protons. So the answer is, because it says row 3, it means that it has 3 energy levels, K, L, M. And because it says 7 electrons, it means M must have 7 electrons and K and L must have full outer energy shells. So the electronic configuration must be K2, L8, M7, because it has 7 electrons in its outer shell, and these are the 3 energy levels, K, L, M. This means that the number of electrons is 2, we get that from here, plus 8, plus 7. 2 plus 8 plus 7 is 17. In a neutral atom, the number of electrons equals the number of protons, which is 17. So Z equals atomic number, which equals 17. Question 4, which is part 4.2. Explain if atom X can lose or gain electrons. So remember, atom X has 7 electrons, and we said that its electronic configuration is K2, L8, M7. Remember that elements like to have a full outer energy level, so this is meant to be 8, and for it to be 8, it would rather gain 1 electron rather than lose its whole 7 electrons and be K2L8. So it would prefer, it's easier for it, it's less energy to gain an electron rather than losing all 7 electrons. Question 1, part 4.3. Calculate the charge of X ion, so of ion X. So the answer is that atom X has 17 electrons. Therefore, in a neutral atom, number of electrons equals number of protons, which equals 17. The charge of the nucleus is the number of protons times charge of 1 proton, plus the number of neutrons times charge of 1 neutron. And we remember we said that neutrons don't have a charge, so it's effectively 0. So it's the number of protons times charge of 1 proton, which equals plus 17. We said that X will gain 1 electron, so it had 17 electrons, and for it to be a stable octet, it will gain 1 electron, so it's 17 plus 1, so that means it will have 18 electrons, okay? It will have 18 electrons. The charge of the electrons in the ion is the number of electrons, so it's 18, times charge of 1 electron, which is minus 1. This will give us minus 18. Please do not forget the signs. So it's minus 18. So the charge of the ion is the charge of the nucleus plus the charge of the cloud. So this is, we got plus 17 from here, and we got minus 18 from here. So the charge of the ion is minus 1. Next question is, write the electron configuration of the X ion. So the answer is that X will gain 1 electron to become X1 minus. Remember, we said that the electron configuration was K2, L8, M7. We said that for it to be a stable octet, it needs to gain 1 more electron, so it will be K2, L8, M8. So look, it has gained 1 electron. It used to have 7 in its outer energy shell. Now it has 8 electrons, so it has gained 1 electron. So the number of electrons will be 17 plus 1, which is 18 electrons. So now the electronic configuration is K2, L8, M8. So now we'll focus on question 2. So question 2, part 1. Determine, using the information in the bar graph, so this bar graph above, the number of neutrons for the oxygen atom. Look, they have given us Z, which is the number of protons, and they've given us the mass number. So from the bar graph, it said that oxygen has 8 protons, so the atomic number is 8. The mass number is 16. Remember, to find out the number of neutrons, we can use this equation, n equals a minus 7. So from the bar graph, we could see that the mass number was 16, the atomic number, so the number of protons was 8. 16 minus 8 equals 8 neutrons. Okay, so we've got 8 neutrons in the oxygen atom. So question 2, part 2, 2.1 says the electron configuration for each of oxygen atom and the calcium atom is, so the oxygen atom has an electronic configuration of K2L6, the calcium atom has an electron configuration of K2L8M8N2. And now we have to identify the placement, so the row and the column of the calcium atom of the periodic table, in the periodic table. So we need to know the row and the column in the periodic table. Remember that the energy shells tells us the row, and the number of electrons in the last energy shell tells us the group, and from the group we can find out the column. So the number of the row is given by the number of energy shells. Remember, the electronic configuration of calcium is K2, L8, M8, N2. Now, it says the number of row is given by the number of energy shells. There are 4 energy shells. 1, 2, so K is the first one, L is the second one, M is the third one, N is the fourth one. So as calcium has 4 energy shells, which is K, L, M, and N, it belongs to row 4. The number of electrons on the outer energy level gives the group number. So the group number is 2. So therefore it belongs to group 2, and which is column 2. So group 2 is effectively column 2. So question 2, part 2, 2.2. So in the part above, they told us the electron configuration for oxygen and calcium. Now we have to write the Lewis dot symbol for each of the mentioned atoms. So we have to write the Lewis dot symbol for oxygen and calcium. Remember, Lewis dot symbol shows the valence electrons. So here the valence electrons for oxygen is 6, and the valence electron for calcium is 2. Before we answer, we have to justify. So the Lewis dot symbol is the arrangement of the valence electrons of the atom. For the calcium and oxygen atom, it is. So for the oxygen atom, we said that the electron configuration is K2, L6. So it's got 6 valence electrons. So 1, 2, 3, 4, 5, 6. So remember, you can draw them like this. And for calcium, it's K2, L8, M8, N2. So it's got 2 valence electrons. So for calcium, we draw it like this. So question 2, part 3, 3.1. A calcium atom loses 2 electrons to attain a stable electron configuration, and a calcium ion having a 2+ charge is obtained. Justify by calculation why the calcium ion has a 2+ charge. So the answer is charge of an ion is the total positive charge plus total of the negative charge. So remember in the bar graph, it told us Z equals 20, so the number of protons is 20. In a neutron atom, the number of protons equals the number of electrons. Now, the electronic configuration for calcium is K2, L8, M8, N2. Calcium needs to have a stable octet. So it needs to either gain 6 electrons or lose these 2 electrons. So it needs to either gain 6 electrons to become K2, L8, M8, N8, or lose these 2 electrons to become K2, L8, M8. Less energy is needed to lose 2 electrons than gaining 6 electrons. So calcium will effectively lose these 2 electrons to become K2, L8, M8. Losing 2 electrons, so it will have 20, so it had 20 electrons. Losing 2 electrons will have -2, so the answer will be 18 electrons. So the number of electrons for calcium 2 plus is 18. So the charge is, remember that it's the charge of the nucleus plus the charge of the electron cloud. Charge of the nucleus is charge of the proton, so it's 20 times 1 plus charge of the electron cloud or the electrons is 18 times 1 minus. So this will give us plus 2. So question 2, part 4. The physician recommends to a patient suffering from osteoporosis a certain medicine. Justify what metal ion should this medicine contain. So we should get the answer from the paragraph given above. The answer is osteoporosis is due to a calcium deficiency. The medicine should contain Ca2+. So now we're going to move on to question 3. Question 3, part 1, 1.1. For each of the hydrogen and F atoms, write the electronic configuration. So first of all, we need to write the electron configuration. So for the H atom, the number of protons, so the Z equals 1. Remember, in a neutral atom, number of protons equals the number of electrons, which also equals 1. So the electron configuration is K1. For the F atom, number of protons equals Z equals 9. In a neutral atom, number of protons equals number of electrons, which also equals 9. So the electron configuration equals K2L7. Question 3, part 1, 1.2. So for each of the H and F atoms, write the Lewis dot symbol. So we have to write the Lewis dot symbol for the H atom and the F atom. So remember, first you have to tell me what a Lewis dot symbol is. So the Lewis dot symbol is the arrangement of the valence electrons on the atom. So for the hydrogen and the fluorine atom, it is. In the text, it's given that hydrogen has 1 electron. It has an atomic number of 1, so we can deduce that in a neutral atom, the number of protons equals the number of electrons, so that's also 1. So it has an electron configuration of K1, and this shows us that it has 1 valence electron. So we draw the hydrogen atom like this. This is the Lewis dot symbol for hydrogen. In the text, it also gives us that fluorine has an atomic number of 9. So in a neutral atom, the number of protons equals the number of electrons. Therefore, its electronic configuration is K2L7. This shows us it has 7 valence electrons. So we can draw fluorine like this. 1, 2, 3, 4, 5, 6, 7. And remember, when 2 electrons are next to each other, we can just draw them as a line. So this is the Lewis dot symbol of hydrogen, and this is the Lewis dot symbol of fluorine. Question 3, part 2. Explain how the bond between H and F atoms is established. Name the type of this bond. So we said that H has 1 valence electron. Fluorine has 7 valence electrons. Remember, we said when 2 electrons are next to each other, we can draw them as lines. Now, hydrogen needs to fulfill its duet rule, and fluorine needs to fulfill its octet rule. So what will happen? This hydrogen electron will share its electron with this fluorine electron. Okay, so the result will look like this. So the H atom needs 1 electron to satisfy the duet rule. The F atom needs 1 electron to satisfy the octet rule. Therefore, each of these atoms will share an electron to satisfy the duet rule for H and the octet rule for F. Both will be saturated and it forms a single. So remember, it forms a single. This is a single covalent bond. So for question 3, part 3, we have to write the Lewis dot structure for the HF molecule. As I explained above, in the last question, hydrogen has 1 valence electron, fluorine has 7 valence electrons. The hydrogen atom will share its electron with the fluorine atom, and this is the Lewis dot symbol for HF. So question 3, part 4, it says state why hydrogen fluoride is always stored in plastic bottles and not in glass bottles, and the answer is in the text above. The answer is hydrogen fluoride is a liquid which attacks glass, therefore it is safer to store it in plastic. So question 3, part 5 says hydrogen can also bond with nitrogen such as NH3. Explain how the bond between H and N atoms is established and name the type of this bond. Just some background information before we answer. We've got NH3. Remember, we said the one that has the most valence electron is put in the middle. So nitrogen has 5 valence electrons. So 1, 2, 3, 4, 5. Hydrogen has 1 valence electron. And each hydrogen will share its electron with one of the nitrogen electrons. So we're at the result will look like this, N like this. So each 3 hydrogen atoms needs 1 electron to satisfy the duet rule. Remember, hydrogen has duet rule. The N atom needs 3 electrons to satisfy the octet rule. Therefore, each hydrogen atom will share an electron with the nitrogen atom. This will satisfy the duet rule for H and the octet rule for N. Both will be saturated and forms 3 single covalent bonds. Look, this is the first one, this is the second one, and this is the third one. So remember, it's 3 single covalent bonds.